we have created a number of classes. For example, I'm going to create two classes, right? We have a class called inheritance example. So in this class, let's put attributes like let's put the attributes, simple attributes like we'd say private string name and age, right? Private string, say the name, but here we're just creating the class. First, we're just creating a class like how we've been creating classes. So we have a private string name and then a private string, a private int age, right? Giving us the name and age of the person. And then we're gonna go ahead and have a method. We have a method called, public void sleep, basically telling us that person is sleeping, right? This, we just wanted to print out that the person is sleeping. Just say, this person is sleeping, right? And then we have public. We have another method. Say the person is eating. Now from sleeping to eating. For the method eat, doesn't take any parameters, and we just print out that the person is eating, right? So this is what we've been doing, where we're talking about classes and attributes and talking about methods, right? So now remember when we spoke about object-oriented programming and the fundamentals of programming, we touched on the concept of inheritance. But before we look at the inheritance part, I want you to take, I want you to visualize this with me. Whenever you're building an application, right? Like I said, an application is just a lot of different classes in Java combining together to actually make sense, right? To make an application, to make something actually function. So those classes, and I also had mentioned that for you to create a class and want that class to work with another class, you have to make the class public using the public keyword that you can see open. Now, sometimes you don't want to redo the class all over again. Maybe you want to use the class but make a small tweak. So that's when inheritance will come in, where you can create a totally different class. Like here, I'll create a class. I'll create a class. And I'll call it find the name. I'll call it A, right? So this is our class A, right? So we just created another class here, class A, right? We have inheritance example, and then we have class A. So now class A also needed, information about, also needed to use, methods. Also needed to use methods like sleep and the method like, eat. But maybe in a little bit slight different way. So instead of coming in here and taking these methods from here and putting it into here and redoing this, see, this becomes a concept called dry. Like, dry meaning don't repeat yourself. So in this case, you're just copying this class, testing it here, and it's just become a whole lot of things that do not make any sense. So as a way to combat that, that's when Java has a concept of inheritance. By inheriting, we're basically saying, I am taking the attributes and the method from one class and giving them to the method of the same class, right? So in this case, this class here which initially had all this information, is going to be referred to as the parent class. The parent class. What does that mean? That means this is the first class that we created. Just like you, if you're a kid, you weren't born before your parents. Your parents were there so that you get born, right? And then as the child, you are technically a subclass of your parent. That's what this actually means. This class was created first. So there's a keyword that you use when you wanna inherit stuff. For example, the keyword is extends. So if you write class A extends inheritance example, by doing this, just by doing this alone, what I've done is I've taken all of these things and attributes that are in class A, and I've made them available class B. Isn't that quite interesting, right? It's interesting that this is basically us saying, copy everything here and paste it here. But then in this case, this is what inheritance is. So in this case, we are saying class A inherited the information from class B. Let's try and see how that is the case, right? So let me create a public method in here, and I'm going to create an object of class A. Create an object of class A. We use the name of the object. We use the class name A. We want to say object A and give it the name of the object. Object A is equals to the new keyword and then the default constructor, like that. So we have created object A, and object A is an object of class A because class A has already inherited elements from the inheritance example class. What do we expect? We expect that if we then use the method, if we then use the object of class A, we have to find the methods that are already part of class A because those methods are inherited from the class above. So in this case, I'll say object A dot. Look at this. I have object A dot it and object A dot sleep. You see, object A dot it. I have object A. I have object A dot sleep. You see that? I was able to get access to. In this case, I was able to get access to the attributes that were, to the methods that were available in class A, that were available in the inheritance class. So in this case now, this thing can go on and on. Okay, now I'm gonna create class B, right? Let's create here class B. And we say class B extends class A. So we have said class B extends class A. So in here, we'll use our main method to print out to help us write the code here. So inside now, inside this class B, I'm gonna create an object of class B to see if we can still have access to the methods that were available in class A, right? And those methods are the same method that came in from the parent class, which is the extend class. So in this case, if this works, B, then we say object B is equals to new, and the name of the default method there. And then if we say B dot, you see now, look at this. Look at this. Look at this. This is no, sorry. We say object B dot. Look at this, right? We have access. We still have access to the methods. You see that? we still have access to the eat and sleep method. But if you look at class B right now, well, this is class B that we're in. There is no method called eat. There is no method called sleep. And just like in here, in class A, there is no method called eat. There is no method called sleep. The only place where we had eat and sleep was actually in the inheritance example, which was the parent class. So the fact that we can have a class extending another class, that means in this case, class A inherited methods from the inheritance example class. After this happened, that means inside here, even though we don't see it with our naked eyes, we have the two methods available here. And then now class B inherited methods from class A, and class A was the one that also inherited the same methods from the inheritance class. So you see how inheritance can work. It can help us provide the availability of methods that we want to use in our application instead of rewriting them all over again or having so many different classes of the same information. Because this helps us to avoid, in this case, in here, we would be having the two methods here, the two methods here, the two methods just keep repeating ourselves, right? And that's something that is not good when it comes to programming, because you want to make it as as clear and as easy to read for somebody else as possible. So that's why inheritance is very important. So that is what inheritance is. It's basically being able to access. Inheritance basically means being able to access methods from a parent class, and you're accessing those methods and then you'll be able to access those methods in the subclass, right? And I think also another thing to note here, let's just say, object A dot. Another thing to note here, as you have noticed that initially, when I initialized my attributes, string name and int age, I initially initialized them as private. So another thing I wanted to explain to you was that usually the reason why the reason why methods are highlighted as public, that means in cases like this, when we when we're inheriting them, we're able to take in those methods from an entirely different class, and then we're able to create objects of those classes, and those objects are able to find those methods. But if you have a method that is static, it can only be accessed from the initial class that you're in. So the same goes to in this case, I was trying to show you an example where my attributes were actually private. With my private attributes, I wasn't able to pick them up in my object. I wasn't able to pick them up when I did the inheritance part. Let me give you a demonstration in here. You see, I have string name. This was private, like that. So private string name. If I come here and I use my object that I created, dot. Look at that. I can only get access to age because age in this case is default, and the default you can get it, you can have access to it. But if you make it private, as you are utilizing encapsulation, it becomes actually harder for somebody else in there who inherited your class to get access to those attributes. So that means two things. If you want to have an attribute that is not accessed by anybody who inherits the class, you can just make it private. The same goes to the method. If your method is static and somebody tries to create an object of that class and tries to access that method, if it's static, you cannot. That's also the reason why we cannot access this public static void main method whenever we're creating an object of that particular class. So I hope all of this made sense.